Exercise 7.11 up to question number 15 we did in the last session. Now let's continue with the question number 16 here. So here I equals to 0 to pi log of 1 plus cosine x dx. So obviously first step is using that property, replace x by pi minus x by a property, by that property, that property very well. So therefore I equals to here integral 0 to pi, this is log of here pi minus x, second quadrant cosine is negative, so 1 minus cos x, cosine pi minus x is minus cos x, this much. Second quadrant cos negative. Now what we do usually, we call the given one as 1, this is 2, and then adding 1 and 2. That's what the normal procedure after using this property. So adding equations 1 and 2. So therefore this I plus I gives us 2i, common integral 0 to pi. You have log a plus log b, so addition becomes multiplication, so 1 plus cos x into 1 minus cosine x. What we did, actually we have added, but you just recall this property, log x plus log y, this is log of x into y, addition becomes multiplication, that you know very well. Okay, now this is nothing but integral 0 to pi log of 1 minus cos square, which is sine square. Sine square means whole square. We'll take this 2 in the product, that is also property of log function. Log of sine x. If you remember, log of x raised to n is n log x. We have used this property, that you know. Okay. Now the 2 will goes away from both the sides. So we are just having I equals to integral 0 to pi log of sine x dx. Now just to continue this, let me see here what we do now. You need to recall one of the important property. I'll use that here as sine pi minus x is because of the second quadrant, it's a sine x. So according to that property, this will be twice integral 0 to pi by 2, limit will be half, remember, here pi by 2, and the function as it is, twice sine x dx. Which property I have used? This one, 0 to 2a fx dx equals to twice integral 0 to a fx dx. If this is true, what? F of x is same as f of 2a minus x. 2a minus x, that's what happening here. Log of sine, log is not important, sine of pi minus x is same as sine x. Pi is this limit, here 2a is the limit, so we have this. Okay, now let's continue further. This little bit different than earlier questions. So now next step is we use again that property, that is replace x by pi by 2 minus x. So again here replace x by pi by 2 minus x by that property. So therefore I equals to twice 0 to pi by 2, this is log of sine x. This become cos x. Why? Because if x is replaced by pi by 2 minus x, so sin pi by 2 minus x gives us cos x. Okay, now we just add again. After using this property, always we add them. So I'll call this as 3 number, I'll call this as 4 here. So adding 3 and 4, normally after using this property we always add them. So now adding 3 and 4. So what is left hand side? I plus I 2i. 2 is common in both, so twice as it is 0 to pi by 2. Again, because of here sin x, let me write one more step here, plus log of cos x here. You could have dropped one step here, directly you could have written addition. Again this 2 will goes away, so I equals to integral 0 to pi by 2. This is log of sin x into cos x. Now I want a function in form of sine. So what I'll do, I want just purely sine function, because here somewhere your sine function. I'll multiply and divide by 2. So therefore I equals to integral 0 to pi by 2. This is log of sin 2x, upon 2 the whole dx. Now we use property of log function again. 0 to pi by 2 log x by y, so it become subtraction, minus here integral 0 to pi by 2 log 2 dx. What I did, division becomes subtraction. That concept I've used here. Which concept? This division becomes subtraction. Okay, now this can be evaluated very easily. So I'll call this as I1. The left hand side was I, minus log 2 will come outside because it's a constant, and here integral of 1, that's x, and 0 to pi by 2. So therefore I equals to I1 minus pi by 2 minus 0. So log 2 into pi by 2. Pi by 2 minus 0. Call this as equation number 5. We keep inside and we find I1, where I1 is what? Integral 0 to pi by 2 log of sin 2x dx. We evaluate this and we place in the equation number 5. Okay, so here for the evaluation of I1, let's do like this. So we take again some substitution to convert into x, remember. So put 2x equals to t, because I want sin x, remember. So 2 times dx equals to dt. So dx equals to half dt. We change the limits. You see, if lower limit is 0 in the I1, put 0 here, then t is also 0. If lower limit is pi by 2, then put here pi by 2. So t becomes pi. 2 will goes away. So therefore I1 would be 0 to, now instead of 0 to pi by 2, limits on t, which is 0 to pi. This is log sin t into half dt. Half I'll keep outside. 1 by 2, 0 to pi log of sin t dt. Okay. Now again here you can see that at this place if I write sin pi minus x, it would be just sin x only. So it's a repetition of earlier procedure. We just make it double here, and we do the half limit as we did earlier. So this is here sin t dt. Why this? Because of sin pi minus t is sine t, as we did earlier. Right, we have used the same property. Because of this, the integral will be double and limit will be half. So this is 0 to pi by 2 log of sine t dt. Okay. Now again replace t by pi by 2 minus x. So therefore I1 equals to 0 to pi by 2 log of, this is cos t dt. What you did, replace t by pi by 2 minus t. So here sin t become cos t, you know it. Now we just add these two, adding above two equations, above two equations. Let's add above two equations. If I add above two equations, what is left hand side? It is 2i1, i1 plus i1, 0 to pi by 2. If you add these two, here you have sin t into cos t. dt. And then what we did earlier, same thing here, multiplying, dividing by 2. So as we did earlier, around equation number 5, you do the same procedure. So you will get here 0 to pi by 2. This is log of sine 2t minus dt minus integral 0 to pi by 2 log 2 dt. Now, therefore 2i1 equals to, you know how to handle the first one. In fact, it is nothing but, if you just go back to earlier equation, it is I1. The first one, it is just I1 minus, what's the value of this? Log 2 into integral of 1 is t and then upper limit minus lower limit. So we have this. Take I1 on this side, so 2i1 minus I1. So I1 equals to minus log 2 into pi by 2. Now we place this value in equation 5. So from equation 5 now, I equals to minus log 2 into pi by 2 minus log 2 into pi by 2. So these are just double here. So minus 2 into log 2 into pi by 2. So this will goes away. So finally we'll get the I equals to minus log 2 into pi. Is the value of integral. It's a nice question, but almost repeated things you did here. So not that much difficult, but you need to do it carefully. Okay. Question number 17 now. That's like earlier questions. Question number 2, 3 and so on. Question number 7 is like 2, 3, I suppose 4, like this only. But I'll do it. Let's take I equals to 0 to a root x upon root x plus root a minus x dx. Okay. Now what we do, we use that result, replace x by pi minus x, a minus x. So here replace x by a minus x by that property. So therefore again I equals to 0 to a, x is replaced by a minus x. So root a minus x upon root x is replaced by a minus x plus a minus x. You can see that just here. It's like this, a minus x. So over here, this will get cancelled. This is just root x dx. Okay, now both the denominators are same. Call this as 1, call this as 2. What we do? We just add 1 and 2. So adding 1 and 2. adding 1 and 2. So what is left hand side? I plus I, that is 2i. Integral 0 to a. This denominator is same, so I'll keep as it is. Just we are adding these two expressions, remember. This plus this. Have a look on this. Denominators are same. What about numerators? Numerators would be added. So you can see that this becomes just 1. This is just 1, you know. What's the integral of 1? That is x. Limits 0 to a. So upper limit minus lower limit, that is just a. So 2i equals to a, and therefore here I equals to a by 2. Their left hand side was 2i. Left hand side was 2i, and right hand side is a, remember. So therefore what is I from this? That is a by 2. That's required integral here. As I told you, this question number 17 is like those questions 2, 3 and 4. Okay, we'll go to question number 19 now. So in the question number 19 here, you are given these two things. F of x is same as f of a minus x, and g of x plus g of a minus x equals to 4. These two things we are given, and we want to prove from LHS to RHS. So I'll start with left hand side integral there. What is left hand side integral? 0 to a fx gx dx. Okay, we keep RHS integral in our mind. So obviously, what is the first step? Replace x by a minus x, because here you have some information about a minus x. So replace x by a minus x. I'll call this as Li. So therefore I equals to integral 0 to a f of a minus x into g of a minus x dx. Okay. Now you are already given that f of a minus x is same as fx. So here 0 to a, this I'll place by fx, because on the right hand side you need fx. What about g of a minus x? I want information about fx only. So here I'll put the value of g of a minus x. So what is that? 4 minus g of x. What I did, I placed the value from this. What is g of a minus x from there? It is nothing but the 4 minus g of x. Okay, now just open this bracket here. So integral 0 to a, this is 4 times fx minus, okay, dx minus integral 0 to a fx dx. I've just opened the bracket. You know that this is just I. I'll take on the left hand side. So this is 2i. 4 will come out. Integral 0 to a fx dx. Okay, and therefore I equals to twice integral 0 to a fx dx. This is, you can see, RHS, right hand side. This is nothing but RHS. We have used just the given information, nothing, remember, not so difficult. Okay, next, now question number 28, which is MCQ. There, if you notice, you have opposite limits. You have opposite limits there. So you should first see whether the function is even or odd, you have opposite limits. Minus pi by 2 to plus pi by 2, x cube plus x cos x plus 10 raised to 5 x plus 1 dx. Right. Now one way is you can integrate, but no need to do that because here this is an odd function here. Cosine is even function, but this is an odd function, so this is also odd function. 10 raised to 5 is also an odd function, so here this much is an odd function. We just now split in this way, therefore minus pi by 2 to pi by 2, x cube plus x cos x plus 10 raised to 5. Why we are thinking for even or odd? Because here you have opposite limit. Plus here integral minus pi by 2 to pi by 2 1 dx. Okay, so this is an odd function, so integral will be 0. This is an odd function. Why an odd function? You can just verify that here if x is replaced by minus x, then that just minus will come out and it is minus fx. This will hold true for this. So according to that property, the value of the first integral is 0. The entire integral is 0. Here x and then upper limit minus lower limit. Upper minus lower, if you do, here it is pi. So correct option is C here. Okay. Next question. Let's see question number 21. So question number 21. Let me call this as I. Always start with I when you are working with definite integral. 0 to pi by 2 log of 4 plus 3 sin x upon 4 plus 3 cosine x. Now this seems to be very complicated expression. You cannot handle by indefinite integral. So obviously property, what we do? Replace x by pi by 2 minus x. You know this well-known property. Whenever you limits from 0 to a, always go for this. So limit remains same. Here sin x become because of pi by 2 minus x cosine x. 4 plus 3, what about cos x? It becomes sin x. If you observe this expression, this one and this one, the one way you can add them, that's one way. We always, after using this property, we can add them. You can add them. Otherwise, this expression is just reciprocal of this. So what I'll do here, I'll rewrite like this. 0 to pi by 2 log of 4 plus 3 sin x upon 4 plus 3 cosine x. I'm just taking the reciprocal of these expressions, so raised to minus 1, the whole dx. What I did, I have just taken the reciprocal. Now we take that minus 1 into the product, you know, that's the property of log function. So therefore I equals to, that minus 1 will come in product, 0 to pi by 2. This is log of 4 plus 3 sin x upon 4 plus 3 cos x. You know this property, log of x raised to n equals to n log x. Now what is this? This is nothing but I in turn. So therefore I equals to minus I, and therefore 2I equals to 0, and therefore I equals to 0, which is nothing but again option C. Let's do some extra examples based on these properties. So here example 1, let's evaluate this integral. 0 to 2 pi sine raised to 5 into cos cube x dx. Now as an indefinite integral this become difficult, but we use that property. Replace x by 2 pi minus x. You know that property. Call this as I, and therefore I equals to here integral 0 to 2 pi sine raised to 5 2 pi minus x into cos cube 2 pi minus x. Integral 0 to 2 pi minus x, which quadrant? Fourth quadrant. You know sign negative, and here your odd power, so minus sine raised to 5. Fourth quadrant cos positive, so cos cube x dx. Now this is in turn again I, so therefore I equals to minus I, therefore take on the left hand side. 2I equals to 0, therefore I equals to 0. Okay, you can try same way this question. I equals to integral 0 to pi sine cube into cos cube. You know how to do this question in indefinite integral. If you remember multiplying dividing by 8, that's one way of doing this, but here use that result. Replace x by pi minus x. Very easily you will get the answer. Replace x by pi minus x. Just try this. Okay, one more question. Let's see this here. Third one. Integral 1 to 2 root x upon root 3 minus x plus root x. Now as an indefinite integral this become difficult to solve. So what we do? We use that property. Which property? Replace x by a plus b minus x. That's the easiest way to handle this question. So here replace x by 1 plus 2 minus x. That is nothing but 3 minus x. Right. Call this as I, and therefore again I equals to integral 1 to 2. X is replaced by this, so root 3 minus x. Here 3 minus x, so here just x, and this is 3 minus x. What will happen in the first term? 3 minus x inside the square root equals to 3 minus x here. So it is just root x, so I wrote here directly. Okay, you know this is always 2, this is 1, adding 1 and 2. Adding 1 and 2. So therefore left hand side is 2i. Integral 1 to 2. What will get inside the bracket? You can check that it is just 1. Now you just integrate it and write upper minus lower. Integral from 1 to 2. 2 minus 1, it is just 1. So I would be 1 by 2. That is required integral here. Okay. Now here you can try such questions also. For example, let's see this. Fourth one. I equals to integral 0 to 2 pi cos cube x dx. So use the property, replace x by 2 pi minus x. Do this. In indefinite integral without limits, you know how to do this, but here with the properties, replace just x by 2 pi minus x. You will see that you will get I equals to 0. Just try to do it. Right. Then here next question. For example, let's see this. Question number 5 here. Integral minus 1 to 1. So you must have realized opposite limits. Ask for the function whether it is even or odd. So what do you think? What about this function? Cos is even function and you have even power. So this is the even function. Sine is an odd and you have odd power. So this is an odd function. So finally product becomes an odd function. So value has to be 0. The value of the integral must be 0. What's the reason? As fx equals to sine cube into cos raised to 4 is an odd function. Why? This question might be there. Why an odd function? You can check. You find f of minus x, replace x by minus x, you will get the minus fx, right? Here you have this, and therefore the value of the integral is 0. So question number 6, one more question. Integral, let me call that as I, pi by 6 to pi by 3 sine 2x into log of 10x. So I'll not do this, I'll just give you the hint how we'll do. Obviously that property, which property? Replace x by pi by 6 plus pi by 3 minus x, that is pi by 2 minus x. Replace x by pi by 6 plus pi by 3 minus x, which is pi by 2 minus x. So you will get I here. Limits would be same, pi by 6 to pi by 3. You try to see what you are getting. Call this as 2, always that's what we do. Call this as 1, and then what we do? We add in 1 and 2. Adding 1 and 2. You just add 1 and 2. You see what you are getting. Your final answer should be, after adding 2i, you simplify, you must get 0, and therefore I equals to 0. Try it. Let's see 7th question. Evaluate I equals to minus 1 to 1 log of 3 minus x upon 3 plus x. So here you have opposite limits. You can check whether this function is even or odd. So let's take fx is this 3 minus x upon 3 plus x. Now what I'll do to check whether it is even or odd, I'll replace x by minus x. So here log of x by minus x. So this 3 plus x upon 3 minus x. Now as we did earlier, you can see the difference here is of reciprocal. So I'll take the reciprocal on both the sides. Just taking here reciprocal. So raised to minus 1. Now this minus 1 will come in product. You know this is the property of the log function. 3 minus x upon 3 plus x. Now what is this? This is nothing but fx, you know. So what you have shown, f of minus x equals to minus fx. So what is your conclusion? F is an odd function. Is an odd function. And therefore the value of the integral is 0 here. The value of the integral equals to 0 because I have shown that it's an odd function. Okay. Question number 8 here. Let's do one more question. I equals to integral minus pi to pi root of 5 plus x raised to 4 into sine cube x dx. Again you opposite limits. As an indefinite integral, it's not easy to integrate. If you observe carefully, here you raised to 4. So your minus sign doesn't affect. So this is an even function. You know that the sine is an odd function and cube is there. So this is an odd function. That means this here, fx is an odd function. This is an odd function. right? You can prove that if you start with f of minus x, you will get the minus fx. That is true here. And therefore, what's the value of the integral? If it is an odd function and you opposite limits, the value of the integral is 0 here. If you have even function, then nothing can be done. You see, question number 9, let's try it. I equals to integral minus pi by 2 to pi by 2 cosine x dx. Now this is an even function. This is an even function. Then the only this much you can do, twice integral 0 to pi by 2, limits from minus pi by 2 to pi by 2, 0 to pi by 2 cos x dx. Okay, and now you know how to get the value of this, so complete it. Okay. One more here. Let's see this question. Question number 10 here. I equals to integral 0 to pi e raised to cosine x upon e raised to cos x plus e raised to minus cos x. You are asked to find the value of this integral. The hint is replace x by pi minus x and simplify, adding 1 and 2 and so on. So final answer is here I equals to pi by 2. Do it, not difficult for you. We did number of such questions. Okay, one more. Let's see here. Question number 11. There you are asked to prove that integral 0 to pi x sin x upon 1 plus cos square x equals to pi square by 4. You are asked to prove this, pi square by 4. So what do? You start with LHS, call that as I, 0 to pi x sin x upon 1 plus cos square. The first obvious step is replace x by pi minus x, call this as 1. If you use this, you'll get one more integral, call this as 2. Then as we did earlier, adding 1 and 2, so we'll get the 2i equals to, you have integral 0 to pi, some expression, then you need to integrate this. Finally, you will get the I equals to pi square by 4, which is your RHS. Do it. I'm sure you can do it if you understood so far the concept. One more question before I stop. Question number 12. I equals to, you have integral pi by 6 to pi by 3, 1 upon 1 plus root cot x dx. Okay. Now what we do, as we did number of times, replace x by a plus b minus x, pi by 6 plus pi by 3 minus x, which is just pi by 2 minus x. Use this, do 2i, I plus I, and simplify. At the end, your final answer is I equals to pi by 12. Try to do this. Final answer is I equals to pi by 12.